guys. So in this video, we're going to be going over properties of logs. And in previous sections, we have taken a look at, well, what is a log and how do we use it and how do we find the values of it? So just a reminder that logs and exponents are inverses. Right? We've already talked about inverses, right? Adding and subtracting are an inverse, multiplication, division, square roots and squares. So logs and an exponential value, they are inverses. So as long as the log base is the same as the base of the exponent, then we can cancel them out and use them as inverses. So we, again, know that they are inverses of each other. So the fact that we have exponent rules means we have log rules or properties of them. And just to go over these real quick, right, we have the product of the powers, meaning if I multiply two powers together or exponents together, I can add their products, their powers. So a to the m times a to the n is really a to the m plus n. We can add those together. Power of a power, I can just multiply, I could distribute and multiply those exponents together. Power product, again, is a distribution. Negative exponents means it's a reciprocal. Zero exponent, anything to zero power is 1. Quotients, if I'm dividing powers, then I can subtract them, right? So m minus n would be the new power here. And on the bottom is just another distribution, 1, just with a fractional form. So those are actually going to be used in logs. We can utilize the same properties. So we're going to work through these explorations together, but I'm going to just actually talk about the answers of them. Because when you work through it, if the fact that I can multiply powers together and add their, multiply exponents together and add their powers, then I can do the same thing with logs. If I have a logs argument, and the argument's the inside value, if they're being multiplied, that means I can actually, what we call expand, I can make it larger by having the log of the one argument plus the log of the second of whatever's being multiplied. Okay. Same thing with our quotients. My quotient rule says that I can subtract powers when I divide those exponents. Well, if I have an argument that is a division problem or a fraction, I can subtract individual logs. Again, I can expand it. I can also go the other way, by the way. I can take two logs that are subtracted and make it into a smaller value of a fraction. So it just depends on if we need something expanded or condensed, and that's what we're going to be getting into today. And the last one is the power property. If I have an exponent, if I have a power, I can actually take that and make it a multiple on the front end of my log. Okay, and that's because, remember, it tells you how many we have. So I can take that n power and do n times that amount of logs. Okay. So there's actually a bunch of questions used to evaluate, and I just want to talk about the answers of them first. So yes, you can put these in a calculator and you're going to get back all the answers. However, if you don't have a calculator, remember the ability to get a log to have the same base as the power will cancel out, right? So when I look at question A, let's say, so I have log base 4 of 16 to the third power. Well, I want to get 16 to be able to be rewritten as a base of 4, so it will cancel. So I need to move that exponent out of the way. So the 3 becomes the coefficient now in front because of my properties I took a look at. And then log base 4 of 16, because that's a 2, because 16 is actually 4 squared, right? And log base 4 of 4 squared, the 4s and the 4s cancel, left with 2. And then I just have to multiply. 3 times 2, remember 3 was the exponent I moved in the beginning, gets me 6. Okay. Question C, remember ln of e, the ln's and the e's are going to actually drop. They're going to cancel each other out. It's the natural log, or the log of the natural number, and e is our natural number. So again, I can move that 2 in front. ln of e is 1. They cancel, and I'm left with 2 plus 5 is 7. If we look at e, right, So I have log base 5 of 75 minus log base 5 of 3. Well, 75 I can't write as a power of 5, but I can split it into something that does have a power of 5. So 75 is actually 25 times 3. And then I can use the rule that the product power, or the product property, that means I can split it and actually expand it to be 25 plus 3, right? It was 25 times 3, but if I take the logs and add them, it's the same rule. So log base 5 of 25 is 2, because 25 is 5 squared. Log base 5 of 3, well, I don't know what that is, but that's okay because I was subtracting a log base 5 of 3, and those would cancel, and I'm just left with 2. So again, if I didn't have a calculator handy and I couldn't figure this out by plugging it in, I can use these rules of knowing that bases and their log bases will cancel out, knowing that I can move exponents to be coefficients, that anything that's multiplied I can create to be an addition, and likely if I had it here, I could make a subtraction problem into a division problem. Okay. Now, again, here's another reason why we can use these. If I'm given a value, if I tell you log base 2 of 3 is about 1.585, log base 2 of 7 is about 2.807. Again, if I don't have a calculator handy, if I just told you these values and you have to use them to simplify, well, then the goal is to be able to create something that I can use log base 2 of 3 and log base 2 of 7. So 3/7 it's a division problem. I can create it to be a subtraction. Log base 2 of 3 minus log base 2 of 7. Numerator minus denominator. If it's a multiplication, right? 21, that's 7 times 3. So I can make an addition problem now. Log base 2 of 3 plus log base 2 of 7. And then 49, I can think of it two different ways. I can do it as 7 squared, and that would be 2 times the log base 2 of 7. Or 49 is 7 times 7. So I can just, create it to be log base 2 of 7 plus log base 2 of 7. You're going to get the same answer in that case. And again, once I'm able to expand it and set it into those logs, I can substitute what I was told they were. 1.585 and 2.807, put them where they belong, and finish my calculations. Okay, so again, this is more for if you don't have a calculator handy or you don't have a calculator that does logs of different bases, which many scientific calculators actually don't do that. So if you don't have access to Desmos like we were showing you, or one of the TI-84s where you can change bases, this is going to be how we need to do it. Right? And again, we'll go through some more of these examples. Let me move myself again. So here's our rules one more time. Product property. If it's a multiplication, I can split its argument into the addition of the two. If it's a fraction, I can split it into a subtraction of the two, numerator minus denominator. And if it's a power, I can move that power to be a coefficient. So we're going to be using this for two different things. We can either expand it or we can condense it. And it depends on the order how we're going to use these properties. If we are expanding, meaning we're taking something small and making it bigger, then we are going to start by getting rid of any division first. Get rid of those fractions. So we'll move them into a subtraction problem. Then we're going to go to multiplications. If we have a multiplication, split that up into an addition. And then the last thing we want to use is our power property. That's always going to be your last thing. Move those to be coefficients. If it says condense, if we have something big and we want to make it smaller, you just go the opposite way. Move the powers up from the coefficient spot to the exponent, condense our addition, condense our subtraction. Okay. Now, if you see grouping signs, then you have to make sure you do those groupings first. Okay. So just be aware of that. Okay. So again, in this example, I had 5x to the 7th over y. That was my argument of the natural log. So the first thing I did was I subtracted. I took that fraction and I made it into a subtraction problem. Numerator minus denominator. Then I noticed, well, 5x to the 7th is 5 times x to the 7th. So I can take that piece, right? And let me get a color here. I can take this piece right here, because again, I know it's multiplication, and I'm going to split it into the addition of those two pieces. And then the last thing I took a look at is this exponent right here. Got to move it. I don't want any exponents. So that becomes now the coefficient of whatever that term is. Now notice I didn't put it in front of everything. I'm only using the terms that I'm looking at. Okay. All right, so let's just do one together. So if we take a look at number 6, right, again, I notice I have a fraction, I have the 5 up top, I have the 12x on the bottom. So I'm going to start by making that a subtraction. ln of 5 minus ln of 12x. Okay, now when I look back at each piece, 5 is just the argument. There's nothing there that is being used with it. But 12x is actually 12 times x. So this guy needs to get simplified or expanded even further. Okay, so ln of 5 I'm not touching. Minus. Now I'm actually grouping, or I'm splitting this group. And since it's a subtraction problem, I do need to make sure I take note of keeping that grouped together. So I am subtracting this whole thing that I'm splitting up. So ln of 12 plus ln of x, right? And it's addition because it was a multiplication problem. Okay. And now the last thing I would do, I have no power, so I don't have to worry about that, but I do want to get rid of the groupings. So I would just distribute that minus sign, right, to both of these. And that should make sense to you because remember in the beginning, I was dividing by this 12x. So I did have to subtract that 12x, which means I have to subtract the 12 and I have to subtract the x, which is what I see I end up doing in the end, because that does have to be a division problem. Okay. All right. So the next thing we're going to take a look at is, well, what if I have to expand it? I'm sorry, condense it. I had something long. I want to make it smaller now. I want to make it one single term. Well, I just go the opposite way. So you can see I started by any coefficient, get rid of it, make it the power. So I saw I had this 3 on the front, made it to the power with the 2 there. Then I have the plus sign, which means it's going to be a multiplication of the 2 of them. So I can multiply 9 times 2 to the 3rd. And then the last thing I noticed, I have this minus sign here, which means it's going to be a fraction. So 9 times 2 to the 3rd is my numerator because that was the first argument. And I'm going to put it over 3 because that's the second argument. And then since these were all numbers, you can actually simplify them. 9 times 2 to the 3rd is 72. 72 divided by 3 is 24. Okay, so if you can simplify completely, you do want to make sure you do that. All right, so again, let's just do one more together. Okay, so let's do this one. Number 8. So again, first thing I want to take notice, these coefficients. That means they're going to become a power. So when I rewrite this, I have ln of 4 plus ln of 3 to the 3rd power now, minus ln of 12. Okay. Then I'm going to take note. I'm going to go in order left to right because there's no grouping here. So I'm going to start with this addition, which actually means it's a multiplication. So this becomes ln of 4 times 3 to the 3rd. And then I have minus ln of 12. Then from here, I'm going to do the subtraction component, right? I see this is subtracted. So I'm going to take that and make it a division problem. So ln of 4 times 3 to the 3rd, that's my numerator because that came first, over 12. And then the last thing I would do would be to simplify that. And in the end, this does come out to ln of 9. Okay, again, so since there were all numbers here, I just threw that in a calculator. 4 times 3 to the third divided by 12. 4 times 3 to the third gets me 108. Divided by 12 gets me the 9. Okay. All right. And we'll go through these real world applications, which is just utilizing all of those skills in a word problem format. The last thing I do want to talk about is something called a change of base. Now, change of base, I'm going to move myself for a minute, really is only done if you have a calculator that does not give you the ability to put a different base log in. So we're using the Desmos graphing calculator in order for us to do this. So we really don't have to change the base, but you do need to be aware of it in case there are directions somewhere that says show the change of base. And a change of base just means you are taking a non-base 10 or a non-common log and you are putting it into common logs or even a natural log I can do. So in this example, log base C of A, well, the C is your base here. It's not a common base and it's not a natural base. I can create it to be one or the other, common or natural, by taking the log of the argument and dividing it by the log of the base of the original. Okay. I can also do with the natural. So I could do ln of A, ln of the argument, over ln of the base. So again, if you're using your cell phone or you're using a regular scientific calculator that doesn't have base logs, you might need to do this in order to simplify something. So real quick, let's just do a few of these just to show you how simple it really is. So basically all you need to know is that the base itself, I'm just going to do these two, that's your denominator. So log base 5 of 8 means I'm going to do log 5. So it's no longer log base 5, it's just log 5. And I put log 8 on top. And then you put that in your calculator and you can get log of 8 divided by log of 5. And again, any scientific calculator would do that for you. And it'll give you about 1.292. Okay. Same thing for number 10. The log of the base is the bottom. So I always remember base bottom, right? Log 8. And then log 14, log of the argument goes on top. And again, just in your calculator, it's about 1.269. All right, now again, just so you're aware, you could also use these as ln. So if I wanted to, I could take ln of 14 over ln of 8. This is your own preference. You are still going to get the exact same number in the end. Okay, so again, if they say use change of base, not base, formula here, that's all they're talking about. You are creating a fraction, splitting up the base that was given to you to create it either as a natural log or a common log. Okay, we're not going to use it as much because we do have access to the Desmos graphing calculator that can find these values for us without having to change them, but I did want to show you that piece.